this would be arcing, minimum of 350 volts. We're able to get to do a air transfer. Just catching the insulation. There we go. Now, enough voltage through our medium, or whatever we're touching to, as a conductor will also work. Water bottle? Just show the button on. Alright, so now it's trying to get from point A to point B, right? We all know that. I mean, it's going to go the path of least resistance. Right now it's got a lot of resistance because the wood is a fairly decent insulator. So we're going to add a little better of a conductor to it, add that water. We've seen water was a conductor this morning, right? And energize that water. But now that we've added something, that conductor to it, it's helping it already transfer through the wood. Of course, the side effect of that is now we're creating that carbon buildup, burning that off, right? So now that carbon is going to become our semi-conductive material. Same thing as the pencil lead that I did, except for it was a really nice big chunk of fuel around it. But I've got basically the same thing, just on a smaller scale. I've got a nice little layer of carbon there. So I've got a semi-conductive material, so it doesn't need my addition of the water necessarily here in a minute. And it's got a nice fuel source. It's got wood, right? And since this is such high voltage, it's wanting to push through there the whole time. But you don't have to have the high voltage if you've got the good semiconductor. Go back to the pencil again. That was only 120 volts, 15 amps. Amperage draw on it was actually really low, metering it across. But since it was a nice big chunk of semiconductor material, that carbon, we had that transfer across there. Same thing on a nick piece of NM cable, build that carbon across it. Non-high voltage event, but still push, sorry. But now we still got that along. I mean, I can let this run for a long time. It's just going to continue to get better.
So what you're saying is, after time, after carbon has built up